So with this conic sections chapter, we've got 4 different shapes that we're going to be looking at. We just did parabolas, now we've got circles, and then we still have ellipses and hyperbolas coming up. So today is our second shape, circles. So we're going to be working on equations of circles and then also graphing those circles. So we're starting off with just a quick definition so you kind of know where this formula comes from, and you'll see why we started off with section 9.1. So equations of circles. A circle is the set of all points in a plane, I guess you could say, that are equidistant from a point called the center. Okay, so set of all points that are equidistant from a point that we call the center. So if you've got that idea set up, if we pick a center anywhere in the plane, so let's say we put it right here, and we call that center HK. We use the same notation, that HK notation, so that you kind of get it straight and that we're not using a bunch of different notation. We call that distance the radius. So when it says equidistant from a point, we call that distance the radius. So you could take that distance anywhere you want and call that the radius. And then we've got some other point on the circle, and so now the circle is every point that is equidistant from that radius. I will tell you, no matter how many times I do this, I am laughably bad at drawing circles. So my apologies, I hope that you are better. All right, so we are equidistant, and then it's all going around that point. So all of these points on this circle should be the same distance away from that center point. That actually was not a terrible circle. I have made much worse. So where this formula comes from is actually technically the distance formula, because this distance is the same as, this distance, which is the same as this distance. And so our equation technically comes from the distance formula, which, like I said, is why we started with section 9.1. So the distance formula, remember, is this. Okay, so we can put all of this stuff together. So if we call this just some random point xy anywhere in the plane, so this specifically is the center. This could be any xy point, and then that distance is called the radius. So square root, we've got the change in x, so this random x value minus the x coordinate of the center squared, plus this random y value minus the y coordinate of the center squared. And then we say that that is equal to the distance, which for this is known as the radius. So what we do is we're not used to having this big giant square root in our circle formula, so we square both sides. So when we square this side, it gets rid of the giant square root, and then you just have the stuff underneath it. And then when you square the right-hand side, it's just r squared. So this is the formula. I'm hoping that looks familiar from geometry, but that's the formula that we're going to be using for a circle, and this is where it comes from. So let's look at a whole bunch of stuff on the next page and a half about circles. So this one right here, this is our very generic centered at the origin formula. So see how this is just an x, this is just a y. So our original center is just starting off at the origin, and then the radius is always r. So if you see an r squared, you just take the square root of that and you get the radius. So this one, your center is h comma k, so opposite, opposite, and then for the radius, we again just square root that number on the side. Okay, so we're going to start first by kind of building our own equations, and then we'll talk about how to graph them. So example 1, plan for park puts the center of a circular pond, this is our radius, 2.5 miles east and 3.8 miles south of the park headquarters. Okay, so if we kind of set that up, 2.5 miles east and then 3.8 miles south. So it's going to be somewhere, just approximate what that would be. And then it's got a radius of about 0.6 miles. Okay, so when we're setting this up, this center is, positive 2.5 and then negative 3.8. So we can use that as h and k, and then our radius is 0.6. So when it says write an equation, we are setting this up. So we would have x minus, and then the x coordinate is 2.5 squared plus, and then move on to that next portion, y minus, and the y-coordinate is negative 3.8. So minus a negative turns into plus 3.8 squared equals, and then this radius squared. So 0.6 squared. So we can square that 0.6. We don't have to square that 0.6. We might as well just to keep things clean. So when you square 6, you get 36. So if you square 0.6, then we would get 0.36. All right, so that would be our final equation that we are looking for there. Okay, so let's do the same thing. Here you've got a graph in front of you, so you're going to be able to pick off what the center is and then figure out what the radius is. So this time they don't give you the radius, but they give you a secondary point on the graph that we can use to figure out. So that is our center right there. That's given as -1, +4. So our center, HK, is given as -1, +4. So we're going to know what that is. And then they give us just some sort of other random coordinate point. And that random coordinate point is -4, +6. So we're going to use these 4 values, plug them into this equation up here, and then figure out what R is. Okay, so our equation, I'm going to write it just so we've got it on the same screen. So the only thing that we don't know is R. We're going to plug these 4 values in right here. So X is -4 minus H, which is -1, so that turns to +1 squared, plus here Y is 6 minus K, which is 4 squared equals R squared. Okay, so we're going to figure out what R squared is, and then we can kind of put that all together. So -4 + 1 is -3. Square it and we get 9. 6 minus 4 is 2. Square it and we get 4. So that is equal to R squared. So that means that R squared is 13. Now, there's really no point in actually square rooting that because our formula requires that we use an R squared. So we know that R squared is 13, so we might as well just plug that right in. So our equation is X minus our value of H, which is -1. So turn that to +1 squared. And then Y minus the value of K, which is 4, equals R squared. And we just figured out that R squared was 13. So we plug that in. So that would be our final equation. Okay, so that's the second way that we can write equations. So here you're handed the center and the radius. Here you're given the center and another point. Here's one more way that you can do this. This is if you've got the endpoints of a diameter. So I want to use a little bit of a sketch to help us out here. So endpoints of the diameter, we've got 3, -3. It's right there. And then 1, 5. Should be right there. So endpoints of the diameter. So basically you're going to have a circle that runs through all of those points. So if these are the endpoints of the diameter, what you can do is figure out what the radius is, which must be halfway in between. So this, again, should remind us of why we just did 9-1 at the beginning of the chapter, because we're going to have to use a midpoint. Okay, so we're going to use a midpoint formula to figure out what the center would be. Okay, so center, midpoint formula, remember, adds the x values together and then divides by 2 to average them out, then adds the y values together and divides that by 2 to average them out. So let's figure out exactly what our center is. So 3 + 1 is 2, 4 divided by 2 is 2. -3 and 5 is 2, divided by 2 is 1. So that is our center, is right there at 2, 1. And then we can use either one of these coordinate points that we want. It doesn't matter. Either way, we'll do basically the same thing that we did up here. So if we choose, let's use this one as our XY point. And then this is our HK point. It doesn't matter. I just randomly picked this one just because they're both positive. I figured I'd stay with the positive numbers. You could easily use this one. You'd get the exact same answer. So we plug all this in. So using just this formula that we've got on the screen still, x minus k becomes 1 minus 2 squared plus, and then y minus k is 5 minus 1 squared, and then we don't yet know what the radius squared is. 1 minus 2 is -1, squared I get 1. 5 minus 1 is 4, squared I get 16. So that is my r squared. Just add them together. So I know that 17 is r squared. So that is going to go in my formula right here. So I'm going to plug in h, k, and then that value of r squared that I just got. So x minus, so I know that h is 2. It's the x coordinate of my center, plus, and then my y coordinate of the center is 1. And r squared is 17. So that would be your final equation. All right, so the second thing that we're going to work on is graphing these circles, and it's actually pretty straightforward once you know how to find the center and find the radius. So let's look at some examples here. Okay, so we've got the equation. First it says find the center and the radius, so you're in this nice standard form here. So this is just x squared plus y squared, which means the center is just 0, 0. And then the radius, remember this right here is supposed to be r squared. So the radius must be the square root of that, which is 4. Okay, so the radius is 4. So here's how we graph them. It's actually super, super easy. Set up a coordinate system. And sorry, that I just did the opposite of what I meant to do there. I was just going to say don't put a dot at the center. Just put some sort of X to mark where the center is. You shouldn't actually have a dot there, just an X. And then since the radius is 4, what we're going to do is go 4 units in all directions and plot a point. Okay, so from the center, we're going 4 units in all directions, and we're going to leave a point there. And then what we do is just connect the dots. All right, so the more equally spaced your lines are, the better these circles are going to be. And so it would look something like that, a little egg-shaped because my points weren't perfectly evenly spaced apart. But this is what the graph of the circle would be like. So you'll be asked to identify these and then graph the circle. Okay, 5 is our last example here. This is in standard form for a conic section. We're going to see these in every single section. What we need to do is get it into our form that we're used to seeing for a circle, and what we do is by completing the square. So you guys are going to get lots and lots of completing the square practice, just like we did with parabolas. So here's the way I recommend you do it. Remember, this is our end goal. I'm going to keep this on our page in front of us. So this is all the X stuff kind of combined up. This is all the Y stuff. And then any constant that we have, we put it on the other side. So that's how I want to organize us first. So kind of group up all the X stuff together. Okay, make your own little group there. Group up the Y stuff together. And then any constants that you have, just push it over to the other side of the equation. So that was a -7. So if you add 7, then it would be a +7 right here. So this is my group of X stuff. This is all I have for Y stuff, and then this is going to become part of my radius squared. So this piece right here, in order to make this look like this, what I'm going to have to do is complete the square. So remember, you start with this term right here, cut it in half, that gives us 3, and then square it, and that gives us 9. Okay, so what we're doing is we are adding in a 9 that did not used to be part of our equation. Since, though, we have this different sort of form of equation, instead of subtracting 9 on the same side, it's better in the case of circles to add it to both sides. So remember, equations, whatever you do to the left, as long as you do it to the right, you kind of keep that balance. So I added the 9 here so that in my next step I can make it look like this. So to balance it, I had to add a 9 right here. So this part right here, that is now all of my X stuff, this factors down. This is X plus 3, X plus 3. So I can write it as X plus 3 squared. This is just a Y squared. If I had more Y stuff, I would do the same thing here. And then this is 16. Okay, so this is now in my normal circle form that I'm used to. So for my center, remember you take the opposite of what you see in here. And then we don't have anything in here, so that coordinate must be 0. And then my radius, this is my radius squared, so just square root it, and we get 4. So I'm going to do the same thing to graph it that I did up here. So start by setting this up. So for your center, don't actually plot a point, just mark where the center is. And then since our radius is 4, we're going to go from this little mark right here, we're going to go 4 units in every direction. So 1, 2, 3, 4, plot a point. 2, 3, 4, so we're going up right there. 1, 2, 3, 4, and then down 2, 3, 4, right there. Okay, that's going to be really lopsided. Graph paper, like I said, will help you kind of make things more evenly spaced out. All right, so that is, if it looks like a circle, that is what your circle should look like.